So what you need to do is, first off, you have this data that I sent to you. So what you need to do is we're just going to start with the room temperature experiment. For the room temperature experiment, we're going to get the times that we found experimentally. This is how long it took the experiment to go to completion. It's actually to go to 10% of completion, but that doesn't really matter. To go to completion. So we get these values and we convert them into K, which is the rate constant. And you could do this by using equation 8 in the lab manual. And K is just equal to 0.104 divided by T, where T is the time. So all I've done is plugged these times into that equation, and I got these values for K that are highlighted right now. Now my next step is to take the average of all these Ks. And that's what I did in this section labeled K average. I just averaged these three numbers and I got the average rate constant. Then my next step was to take the negative log of this K average, and I've also done this to the right, negative log of K, and I got 1.71395, etc. Now, the next thing we have to do is we have to take the average temperature in which these experiments were conducted. So you can see that the average temperature I got in degrees Celsius is 21.333. We need to convert this average temperature in degrees Celsius to average temperature in Kelvin. So you could find the equation for converting between Celsius and Kelvin on Google, but it's a pretty easy thing to do. And you can see I've done it here. And then the last step, the very last thing we have to do is we take this Kelvin, temperature in Kelvin, and we find 1 over temperature, right? So we get 1 and divided by this temperature that we found in Kelvin, and I got this, 0.0033958. So I've done this for the room temperature, and we just do the same exact thing for the hot trial and the cold trial. So we find all this data. And then with the data, what we're going to do is we're going to make a table with 1 over temperature in degrees Kelvin as your x value and negative log of k as your y value. Now for each trial, we're going to get one of each, right? So for the room temperature, we're going to get 1 over temperature and we're going to get negative log of k. Same thing for the hot trials, same thing for the cold trial, right? So we're going to have 3 points, basically. So what we're going to do is make a graph out of this data. We highlight the graph. We go to Insert. We go to Charts. Click the drop-down menu. We want a scatter plot. So you click Scatter. There you go. You have your graph. Now we just need to insert a trend line. So we go to the upper left-hand corner where it says Add Chart Elements. And in this section, you could add not only a trend line, but change the axes and add axis titles, which is very important. But for now, we're just going to go down to trend line. We're going to go down to more trend line options. This is going to open this menu on the right. And if we go over to the little bars that says trend line options, we click on that. We select linear trend line. That's what we want, a linear trend line, since our data is linear. Then we go all the way to the bottom and we click check off display equation on chart. And we also check off display R squared value on chart. Now we're just going to move this to somewhere where you can see it. Now we could see that it gave us a formula for a straight line, and it's the form y equals mx plus b. So we see our slope is the one next to the x. So our slope is 3,618.3. Now I'm just going to move this to the side because I've already done this with the axes labeled and the appropriate chart title. So I want to see this when you turn in the report. So now that we have found the slope, we need to determine the units of the slope. So one thing I need to point out before we do that is that the units for the y-axis, the negative log of k, it is unitless, right? And the units for the x-axis is 1 over Kelvin. So to find the units, remember that the slope is rise over run. So what we have to do is we have to divide the units on our y-axis by the units on our x-axis. Now, since the y-axis is unitless, we're just going to plug in a 1 where the y is. And we know that the x-axis, the units on there is 1 over k. So we'll plug in 1 over k where k is Kelvin, where x is. Then we simplify that fraction, and the units that we get is the units for the slope. Now, once we have our slope with the appropriate units, all we have to do to find the activation energy, which is what that question is asking for, is plug it in to this equation right here. M is equal to activation energy, which is EA, divided by 2.30 R. Now, R is the gas constant, and there's many different versions of the gas constant, or values, I should say. And the value that you want to use is the one that has joules associated with it. So just Google the values for the gas constant R and find one that has units of joules. It has other stuff too, but I'm pretty confident that it's the only one that has joules in it. So use that one, plug it into this equation, plug in your slope as well with the appropriate units, solve for activation energy, and that's it.